Okay, so this problem says a mole of ideal monoatomic gas at 0 degrees Celsius in 1 atmosphere is warmed to expand isobarically uh, to triple its volume. How much heat is transferred during this process? So, um, so this is an isobaric process, and so the amount of heat QP is NCP times delta T, and well, we don't know delta T, we know this. And Cp for an ideal monoatomic gas is Cv plus R. Cv is 3/2 R, is 5/2 R. Okay. All right, so now let's find delta T. PV equal to nRT, and this is an isobaric process, so P is constant, and when the volume changes, the temperature changes proportionally. Okay, so P times delta V equal to N R delta T. So the change in temperature is P delta V divided by N R. Okay, and we'll substitute that in the expression for QP. So QP is N Cp times delta T, which is P delta V N R. Then cancels. Cp is 5/2 R times P delta V over R, and the R cancels as well. So the amount of heat added in this isobaric process is 5/2 P times change in volume. Okay. Oh, triple its volume. So we'll have to find the initial volume. Okay. Oh, this is crazy. Okay, 5/2. Now let me find the initial volume. Um, so, so that's the expression, but we're not done yet. P initial V initial equal to N R T initial. All right, we'll need a. So initial volume is N R T initial P initial. And the reason we found this is, okay, if you guys are okay with this, so delta V is V final minus V final was 3V initial. So delta V was 2 times V initial. Okay. All right, so we'll bring the expression for QP here. QP is 5/2 P. It's an isobaric process, so P is P initial times delta V, which is 5/2 PI 2VI. So QP is 5/2 PI 2 VI. VI is NRTI PI. Just doing a whole bunch of algebra to simplify all this stuff. Okay. So the heat added is 5 times NRTI. There you go. Okay. We know the initial temperature. We know the number of moles of gas you have. And so this is easy now. Okay. All right, so this is how much heat you added in this isobaric process. N is 1 mole. R is 8.314 joules per mole per Kelvin. And the initial temperature is 273 Kelvin. Okay. So we've added 5 times 8.314 to 273. 11,349 joules. Okay. Can anybody tell me what the final temperature is? It's hidden in all of that. Okay, so here, see, when we triple the volume, the temperature tripled. So it went from 273 to 3 times 273. So roughly close to around 900 degree Kelvin. Okay. All right. So if we don't have any questions, we'll end this problem.